So a few things. One, the annual student update. I told you guys about it very beginning of the year that there would be a time when they shut off the access to your school accounts if that is not done. That's why on the syllabus that I made all your parents like sign and return to me, they had to initial that they did it. However, I got a list of like a bunch of students that still haven't done it that will lose access to their school accounts on Monday. And it's super inconvenient because then it takes like days to get access again. Even if your parents like completed on Monday or whatever, it would take days for you to gain access again. So people, as of like the day before yesterday, that still need to do it are Scarlett, Michaela, Angelina, Kendall, Cohen, Ryan, Dinah. Yeah, or you're gonna lose access starting Monday.
I've done mine.
Adriana, Danica, Lauren, and that's it for this class. And your parents might have already done it like within yesterday or like, I don't know, within yesterday, because I did email home all of you and your parents. But if your parents' info isn't up to date, which is what that's all about, then they're probably not getting that email. So that's why we make you guys do it. And that's why they shut off your account when you don't. So make sure, super important, you're still responsible for all the work, even if you're locked out of your accounts. So make sure that doesn't happen by making sure your parents do it over the weekend. All right. Anyway, we are on the last lesson of Unit 2. Very exciting. I mean, we still have a second part of Unit 2, but we split Unit 2 into 2 parts because otherwise that'd be like almost 30 lessons. All right, we split it into 2 parts. So the first part's all about linear equations and linear systems. The second part, which you'll start after break, is linear inequalities and systems of linear inequalities. So very exciting. But next week we are just reviewing and testing on the first part of Unit 2. So today's lesson is focused on how many solutions a system of equations could have. We already touched on that during the graphing lesson, so hopefully that's pretty clear how you can tell when it's graphed. But since we learned substitution and elimination, we'll also talk about how you can tell algebraically, like when you see certain situations in a problem, that it's no solution or infinitely many solutions. You've already seen tons of examples where it's one solution. All right, but now we'll show you how it looks for the other ways. I'm recording right now, like always. So if you've been absent for whatever reason, it could be a really good reason, you are still responsible for knowing all the material. So at a minimum, make sure that you're taking notes, going back, watching the videos, because 1, we have a binder check next week, and that's going to be a good chunk of points. And 2, like you still have to take the same test as everyone else. In order to receive credit, you still have to know the same skills. So make sure we're staying on top of that. You do have a practice called lesson 17 for today. And these are available for studying already. So I wanted to make sure I had them ready prior to the weekend so that you could get ahead. Combined, these are 150 classwork points. That's equal to like 15 other homework assignments. So if I were you, I would really pour my energy into making sure I understand everything on both of these. So that 1, that helps me for the test that I'd be taking on Wednesday if I were you. And 2, it's worth more points than if you went back and did all your other assignments that might be still missing. I mean, you should still do them, but combined, I think like the first puzzle piece shown on here is like 13 or 14 questions. And then this one, which I'll pass out the paper on Monday, but you could click and see what it looks like already if you wanted to get ahead, is like the same 3 questions that you would get on your constructive response test. So not that many questions, but it's worth a whole bunch of points because it's really important. It's aligned to your actual test. So any questions on that? All right, this list is also in Schoology. So in the slides, feel free to get your binder ready over the weekend. That'll be worth 36 points in your project category. So when you have a 0 in the project category, that brings your grade way down. If you notice that from the last binder check you did. So make sure that at a minimum, you don't even have to be like a genius to take notes. You just have to like care enough to want to like take some notes to make sure that we are doing the bare minimum, which is writing down the stuff we do in class. So any questions?
No, ma'am.
All right, so then on to the warm up. Andre is trying to solve the system of equations. Looking at the first equation, we thought the solution to the system is a pair of numbers that add up to 3. Would you agree with that observation?
Yeah.
Okay, yeah, it says x plus y equals 3. So the solution, the values that make x and y true, or both equations true, would have to add up to 3. It says, I wonder which 2 numbers they are. So choose any 2 numbers that add up to 3. Let the first one be the x value and the second one be the y value. Table 7, can you tell me what 2 numbers you picked? 2 and 1. So they said, let the first one be the x, let the second one be the y. For the pair of values that you chose, that we know work for the first equation, because 2 plus 1 is 3, we're going to check if it's also a solution to the second equation. How could I check that? Just plug it in. So if we're saying that x is 2 and I plug it in, it'll look something like this. So 4 times x, which we said that's 2, equal to 12 minus 4y, which what did we say the y was? And if it's equal, then it's true. So what's 4 times 8?
32.
I'm sorry, what is it?
32. 4 times 8. 32.
Oh. Okay, you guys are right then. So I was like, what? What's 4 times 2? Okay, sorry. And then what over here, let's see who knows our order of operations. Would I subtract first or multiply first? What's negative 4 times 1? And then what's 12 minus 4?
8.
So is this true? Does 8 equal 8?
Yeah.
So yes, it is a solution to the second equation. Then it says try again with the different set of numbers that add up to 3 and see if those also work in the situation. So table 8, what other numbers also add up to 3? 1.5 and 1.5. Those add up to 3. If I plug it in, does it give me the same, does it give me something that's true? Table 8. Did you guys plug it in already? Okay, so then let's do that real quick altogether. So this time we're plugging in 1.5 for the x and the y. What's 4 times 1.5 class?
So what?
4 times 1.5? Okay, good. On the right hand side, multiply first. What's negative 4 times 1.5?
-6.
And then what is 12 minus 6?
6.
So is this true?
Yeah.
So yeah, it is a solution. What are some other numbers we picked? That would also work for both. I'm sorry, what was that, Benji?
There's more. There's more.
Yeah, there's more you could do. What are some examples? Anyone? What did you say, Andre?
3 and 0.
3 and 0.
Okay.
What else could I put, class?
0.5 equals 0.5.
0.5 and 2.5. Does anyone have an example with the negatives? Or could you give me one with a negative? No one can think of any negative number that when you add it to another number, it gives us 3. 4 and -1 in either order. And what you should have seen is that when I plug in any of these, it does happen to work for both. Even just seeing that it works for the first two that we actually plugged in and showed the work, we know that this system has more than one solution. And there's not that many options for how many solutions a system can have. So if it has more than one, then what's my final answer for how many this problem has for solutions? Say it loud and proud, I can't really hear. If it's not one solution, for this one, it's gonna be infinitely many solutions. But it's not like we're plugging in the numbers and it's not working, it is working. And it's working even when we plug in all these numbers. So in that case, if it's more than one solution, that works for X and Y, then we have infinitely many solutions for this system. Questions, comments, concerns? All right, now guessing and checking, that's what that method would be called. It's just thinking of what X and Y could be and just seeing if it's true. That's probably not like the best method to use when you're solving systems. So use any of the other methods that we've done already. All right, but just showing you it did work for both as long as it added up to 3 and then we plugged it in and it did work. Questions on that? All right, so this next problem is really great practice for your constructed response piece next week, where you don't get like multiple choice options, where you have to make the equations yourself. So try this as an individual. I'll let you know when to share with your groups. But we have a recreation center is offering special prices on its pool passes and gym memberships for the summer. On the first day of the offering, a family paid $96 for 4 pool passes and 2 gym memberships. Later that day, an individual bought a pool pass for herself, a pool pass for her friend, and 1 gym membership. She paid $72. So let's see how you do alone as an individual. Try writing a system of equations that would represent that situation. With the pool passes, gym memberships, and the cost. I'll give you like 1 minute alone, so no talking during that 1 minute. Now, don't tell me the answer, listen to the question I'm asking. So I already mentioned it's a system of equations. Equations have equal signs. You could have at least 2 equal signs. Table 9, can you remember what I said would be really helpful if you don't know where to begin, what to look at first?
We don't remember.
Sorry, what did you say? You don't remember? Is that what you said? So think about it. What's a good starting point? Look at the problem. Look at all the information it gives you. It gives you a lot. Okay, and what would be the most helpful to start with? How much money they spent. So in other words, totals. It could be like a total amount they bought, a total amount they spent. In this case, we're talking about 2 different people spending different amounts of money. So what are my 2 totals, table 9? Okay, great. And that's really helpful because then that tells me or gives me an idea of what I should put on the other side. It contributes to that total. So then table 1, what contributes to the total of $96? And how can I translate that to like numbers and symbols? Okay, good. And what is the P representing, class?
Pool passes.
Like the number of pool passes?
Yeah. Number of pool passes they bought. The price for one.
Oh, the price.
the cost of the pool pass, because we know how many they bought, we know they bought 4. And that'll be another part of your constructed response too, is defining your variables. The P would be the cost, that's what we're trying to figure out, that's why it's an unknown, variable. And then G would be the cost of the,
Gym passes or gym
Okay.
memberships.
good. All right, because you know they bought 4 of one and 2 of the other, so that makes sense. Then table 2, can you tell me what to put on the other side of the 72? What contributed to the $72 pool? Question or answer?
Answer.
Okay, we'll listen to it. Okay.
Oh, one fee for speaking, 72.
Okay, do you guys agree? Okay, what's wrong?
Pool tax.
Okay, I agree with that. Cause when you reread it, when we reread it, it says a person bought a pool pass for themselves, a pool pass for a friend, so one person went to 2 pool passes, and 1 gym membership. But good. All right. Questions on that? So if you didn't get that, I just gave you a lot of strategies right now. We know we're talking about equation. You know it's a system. There should be 2 separate equations. So that should be 2 separate totals. Think logically. What contributes to that total? What do we know? What do we not know? Unknowns should be variables. Make sense? Okay. So then that's the first part. Number 2 says that we need to find the price of each algebraically. So algebraically means not by graphing. Okay, I know you love graphing, I know it's super easy, but you still need to know how to solve algebraically because you will be asked those procedure type questions on your test. So, what are my methods of solving algebraically for systems? We learned 3 methods. We're not doing graphing, but what were the other 2? Elimination is one of them. And what's the other one? Okay, great. So you have an option. Do you want to do it by elimination or substitution? Okay, I agree. I think elimination is easier, especially compared to substitution. I think substitution, there's a lot of room to make mistakes. There's a lot of steps. But for elimination, would I be able to just add or subtract these like how they are? What would I have to do first? Because you're right, adding or subtracting the way that they are right now wouldn't eliminate any variables. So I should do what, Julie?
Multiply the one thing.
And what would you multiply it by? 2. What variable are you hoping to eliminate? The P or the G? There's no wrong answer. Oh, you want to eliminate both, okay. That is what happens on this one, just so you know. But if you were problem solving, you just kind of pick a variable and think like, oh, is there a way I can go from 2 to get 4? Yeah, multiplying by 2. Or if you decided you wanted to eliminate the G, think, is there a way to go from 1 to get 2? Multiplying by 2 also works. So yeah, so you would multiply the entire thing, entire equation by 2. What's 2 times 2p? 4. 4p. And then what's 2 times g? And 2 times 72. Okay, good. 144 is right. So we manipulated this equation. I can pair it with now the top equation, which we didn't eliminate, or we didn't manipulate at all. And now that I have a common coefficient, I can add or subtract them? Would I need to add or subtract to eliminate? Subtract, because we have the same sign subtract. What's 4p minus 4p? 0. What's 2g minus 2g? So we actually eliminated both variables, but keep going, because what we see next will determine if we have no solution or infinitely many. But then what's 144 minus 96? 48. 0 plus 0 is, does 0 equal 48? So this is not true. False. So what does that mean? Do you think there's no solution or infinitely many? And that would be our answer for this one. So if you're solving it algebraically and you see something like this where both the variables eliminate, and you could have also seen it in substitution too, both of the variables would have eliminated at some point. It would be like having 2g minus 2g, like it would cancel out. You have to see what your resulting equation is. If it's true, then you have infinitely many. So it would say something like 0 equals 0, which is true. But if it's 0 equals something else or just something else that is not true, it's no solution. How could I verify graphically? What would my no solution graph look like? Anyone remember? Okay, well then maybe we'll see it and we can talk about it later. But now we're gonna do a card sort. So you have in your baskets a different card sort than the one from yesterday. You're gonna sort the cards into 3 groups, where there's one solution, no solution, or infinitely many. You've learned lots of ways to solve. So you need to now use those ways, whatever you think would be quicker, most logical, to answer the card sort. Yes. Okay. I need you to listen to me. For this random like pool pass gym membership situation, if there's no solution, what does that mean? Like in that real world context? If there's no solution to this, and this was like trying to figure out what the pool passes cost and what the gym memberships cost, and I get that it's no solution for the system, what does that mean in the situation? Did they pay the same amount? No, there's no value of the pool pass cost or the gym membership cost that would make both situations true. So they must have paid different amounts for each. Okay, now keep going with the card sort. Here's what you're doing. You're sorting into 3 groups and be prepared to explain how you know. Table 3, can you tell me which card, there's one of them, has no solution? So there's 2, just tell me one of them. Okay, they say that card 5 has no solution. Do you guys agree?
Yes.
Okay, give me some strategies for how to figure that out. Okay, you could use a graphing calculator. When I graph it, do I have to rearrange it?
No.
No, if you graph it by hand, you might need to put it in slope-intercept form so you could see your slope and y-intercept. But when you graph it, what does it look like? They don't intersect. How do you know that they don't intersect? I mean, you can't see like the entire graph all at once. How do you know that they're never going to intersect? Because they produce parallel lines. Parallel lines have what the same about them, class? They have the same slope, so I'm going to put same m because m is for slope. And then what about their y-intercepts? Are their y-intercepts the same? They would have different, otherwise if it was the same slope, same y-intercept, it'd be the same line. So they have to have different y-intercepts. I'm gonna put different b, so that way you know your y-intercept is b, or at least you're supposed to know that. Questions on that? You could start filling out your table too. Like we just went over what a no solution graph would look like. We don't intersect. They have the same slope, different y-intercept. Table 4, is there another card that has no solution? Okay, card 2, would you guys agree, class? Now, I would say that this one, you don't have to put in the graphing calculator, but if you did, you would also see parallel lines. These are already in slope-intercept form. You can see the slope is the same, but the y-intercepts are not. So parallel lines will never intersect. So that is right. Table 5, are there any others that have no solution? Okay, so let's look at 7. They're saying that they have no solution for that one. Do you guys agree? Okay, I saw a few head shakes. No, I'm not hearing anything else. So let's see. The way that this is set up, I could not easily do elimination because I would have to rearrange it so that they are lined up. I mean, that wouldn't take many steps, but still like more time consuming. What's another easy way to check? By graphing. That's what I would do. So when I type number 7 in, let's see, or card 7 in, here's what I'm seeing. Now, what happened to my red line? It disappeared because the blue line's right on top of it. They're overlapping each other. They're the same line, same slope, same y-intercept. If I rearrange these both to y equals mx plus b, I'd have the same exact line. So in that case, it's not going to be that it's no solution. What's it going to be? So infinitely many is what card 7 should be. If you solved it algebraically, you would have had something where they eliminate, but the equation it says is still true, like 0 equals 0. That would be true. Questions on that? So 7 is actually infinitely many solutions. Table 6, can you tell me, are there any other cards that are no solution? Okay, can you tell me, so that's right, only 2 cards were no solution. Could you tell me a card that has just one solution? Card 1, so let's look at that. We're saying this one has one solution, would you guys agree? So look at it. It's in slope-intercept form. That makes it really easy. You can do it without even putting it in your calculator. Do they have the same slope? No. So then that's automatically one solution. They would have the same slope if it was no solution and infinitely many. So you already know it's just one solution. Good. Table 7, can you tell me another one that has just one solution? Okay, card 4, do we agree, class? All right, I agree as well. If I were to rearrange this in a slope-intercept form, so I'd have to subtract 3x from the first equation on each side. There's what it looks like in slope-intercept form. Over here, I have to divide 3 from all of them. You probably did it a different way, but I'm just showing you, here's another way you could look at it. In slope intercept form, my top equation has a slope of what? What's the slope of the equation that I have my mouse on? Probably take a look at it. Look at the thing I have my mouse on. What's the slope of that? -3, because that's the number that's in front of the x. Is that the same slope for this bottom one down here? Where it looks like -x/3, what fraction is that actually? -1/3, so those are not the same slopes. So automatically one solution. Questions on that? Table 8, what's another one that has just one solution? Card 9, do we agree, class? All right, that one's easy to see. It's already in slope intercept form, different slopes. That's the only option when there's different slopes, so one solution. Then table 9, are there any more that have just one solution? Okay, which one? All right, and I agree. Again, I know graphing's probably easier, but the way it's lined up, I probably solve by elimination. Would I need to add or subtract to eliminate the x? Subtract, and then that eliminates the x. Does it eliminate the y? What's -1 minus a -4? Correct. But my question was, does it eliminate the y, class? So I automatically know it didn't eliminate both variables. There will be one answer. Okay, does that make sense? We'll add you to the list. All right, table 1. Are there any others that have just one solution? Okay, can you tell me, well, I guess if that's true, then these other ones must be what, class? Infinitely many solutions. And what do the graphs look like for these situations? What was that? A straight line. How many? It'll just look like one line is graphed, even though you graph a few things. It'll be right on top of each other. If you reduce them all to slope intercept form, it'll all be the same exact equation. Questions, comments, concerns? Okay, so using what we just talked about, fill in this table. I'm gonna switch. Fill in this table. I put some examples here. You don't have to use these ones. You could use a different one that you like better. But these are all from the card sort. But you need to write down what it means and what it looks like on the graph. I'm confident you could tell me what it looks like on the graph. What it means, I feel like was trickier earlier. So fill out that table. I'll give you like 2 to 3 minutes to fill out the table before I tell you what it should say. Let's see if you're right. Definition, I feel like people have been struggling with. So let's talk about if it's one solution. A solution to a system would be what if it's just one solution? So if we'll think back to that pool pass gym membership word problem we did earlier. When there was no solutions, what did that mean about the variables? No values for X and Y. Make both equations true. All right, there would be no values for X and Y that make both equations true. What it looks like, you could say parallel lines there, sorry. You could say same slope, different y-intercept over here, what the graph looks like. But in context of the situation, there's no values for the variables that make both true. So then for one solution, what does that mean? Kind of model it after this. If there's only one solution, that means
Only one value that makes it true.
only one XY value, so it has to be the two variables. Only one XY value makes both true. Now, if it's infinitely many solutions, what does that mean? Okay, perfect. You guys are catching on faster than earlier. But yeah, many solutions for XY that make both equations true. Doesn't mean all combinations will make it true, but like specific combinations, there's tons of them that will make both equations true. Is that making sense? Okay. So yeah, that covers all of the first part of unit 2. So don't just pack up and wait. We still have 7 minutes. I think there's probably 7 problems on your homework, maybe less. Get a decent amount done. You can start working on those study guides. Lots of things. So no one should be sitting staring at their phone.